chemistry tutorials on the part 2 of calculation of molecular mass. I remain Benjamin. Let's start with the example on the board. An organic compound X contains 40% carbon, 6.7% hydrogen, and the other component oxygen. If the relative mass of the compound is 60, calculate there. The first one is the empirical formula of X, and the second one is the molecular formula of X. Like we've been doing before, if you have not watched our previous video, please go and watch in empirical formula and also in molecular formula 1. Now let's go to starting, because we have 3 elements: carbon, hydrogen, and oxygen. Now carbon have 40%. 40% divided by the relative atomic mass, which is 12. So that will give us, alright, here 3 elements are given to us. Carbon is 40% divided by the relative atomic mass, which is 12. That will give us 3.33. And hydrogen, the percentage was 6.7 divided by the relative atomic mass, which is 1. That gives us 6.7. Oxygen, the percentage was not given. Therefore, we remember that percentage of oxygen plus percentage of carbon plus percentage of hydrogen will be equals to 100. If the percentage of oxygen is X, then X plus percentage of carbon is 40, then plus percentage of hydrogen is 6.7 equals to 100. Now we have, like numbers here, we have X plus 46.7 will be equals to 100. So we collect like terms. So that will give us X will be equals to 100 minus, we cross this to the other side, we cross to the other side, it becomes minus, so minus 46.7. That will give us X is equals to 53.3. Now this is the percentage of oxygen. So that will give us, for oxygen will be equals to 53.3 over 16, which is the relative atomic mass. That will give us 3.33. Now from our solution here, you see that the smallest is the ratio between carbon and oxygen. So what you need to do is we divide through by the smallest ratio. I hope you are following me. We divide through by the smallest ratio. We have 2 small ratios. These are the ratio of carbon and oxygen. Now let's go to the other side where we have space to continue. For carbon, the ratio here is 3.33. Then divide by the smallest, 3.33. The answer is 1. For hydrogen is equals to 6.7 divided by 3.33. The answer will be equals to 2.01, approximately 2. So oxygen, the ratio here was 3.33 divided by 3.33. Wonderful. You are already there. So it's 1. Therefore, the empirical formula for this compound is C1. Remember, in chemistry, you do not write 1. And H2 and O1. That is the empirical formula. Now, to get your molecular formula, remember, it's equals to empirical formula into N is equals to molecular mass. You are already there. Very simple. Now, you bring in the empirical formula here. This will give you CH2O into N. Your molecular mass from the question was 60. Very simple. So 60 here, and then you expand your bracket. That will give us 1 times C plus 2 times H plus 1 times O into N is equals to 60. So we have this to be bracket 1 times 12 plus 2 times 1 plus 1 times 16, N is equals to 60. Now we have here bracket 12 plus 2 plus 16 into N is equals to 60. So we have this to be the 30 into N is equals to 60. And so 30N is equals to 60. Making N the subject of the formula, we have 60 divided by 30, which give us 2. You are already there. Now, look at this. We could not multiply this 60 by 2 because from this question here, the relative mass was 60 and not vapor density. You can only multiply that 60 if vapor density is given, but you cannot multiply when the relative mass is already given. That's why we did not multiply. Now let's go back to our final answer, which is 2. So our N is 2. Now we pick N into the empirical formula as we move down here. Our empirical formula was C2O. Our N is now 2. So we have C2 multiply this H4 and O2. That was interesting, isn't it? And in this example, a compound contains nitrogen, hydrogen, and chlorine in the following percentage composition by mass. Nitrogen is 26.17%, hydrogen is 7.47%, chlorine is 66.35%. And you are asked to determine its 1, empirical formula, 2, molecular formula, if its vapor density is 26.75. Let's go over to the solution. There are 3 elements here. So we have nitrogen will be equals to the percentage, which is 26.17 over 14. That will give us 1 point equals to 1.869. And then we go over to hydrogen, which is 7.47 over 1. That will give us 7.47. And we go to chlorine, which is the percentages of chlorine is 66.35 over 35.5. Hope you know where 35.5 is coming from. That is 869, 1.869. So divide through by the smallest ratio. That will give us to be N, which is nitrogen, is equals to 1.869 over 1.869. It is equals to 1. Hydrogen will be equals to 7.47 over 1.869. This is equals to 3.99, approximately 4. So we have oxygen to be 1.869. Not oxygen, chlorine. We have chlorine to be 1.869 divided by 1.869 is equals to 1. And so your empirical formula will be equals to N1, H4, and Cl1. Wonderful. This, you know this formula. You have come across it in the laboratory. This is ammonium chloride. It's wonderful. A substance that undergoes sublimation when it's exposed to air. Now let's go over to calculating the the molecular formula from this. Molecular formula will be equals to the empirical formula, which is NH4Cl. N is equals to molecular mass. And here we have 1 times N plus 1 times plus 4 times H plus 1 times Cl. N is equals to 2 times Vd. Alright? You know what Vd means? Vapor density. This is 1 times 14 plus 4 times 1 plus 1 times 35.5. N is equals to 2 times 20. The vapor density from the question was 26.75. 26.75. That will give us this to be equals to, this is bracket. This will give us a total of, when you add this all, you have bracket 14 plus 1 plus 4 plus 35.5. N is equals to 53.5. And so we have this. When you add this all, you have 53.5. N is equals to 53.5. And so when you multiply, you have 53 point, removing the bracket, 5N is equals to 53.5. Now in this case, N will be equals to, dividing both sides with 53.5, will equals to 53.5 over 53.5. This will give us 1. Therefore, you can see that the molecular formula in this case is the same thing like the empirical formula. Let's bring the empirical formula first. The molecular formula will be equals to empirical formula, which was bracket NH4Cl, and you bring down your 1, which is the N. So this will give us the same thing, NH4Cl. That was wonderful. You can see that the answer of the empirical formula is the same like the molecular formula. It's always possible for you to come across this. So you can have this as your assignment. Do the following assignment and submit to our comment box. What is the molecular formula of a compound with empirical formula CH2 and vapor density of 90? A certain compound on analysis yielded 4.00 grams carbon and 0.68 grams hydrogen and 5.34 oxygen. If the vapor density of the compound is 30, calculate this molecular formula. This is wonderful. Drop your answers in our comment box and we shall get back to you. If you have not yet subscribed, please click on the subscription button for more videos. Thank you for watching.